A powerful way to manage availability, high availability for VMs is through what's called a VM scale set. A VM scale set is a set of VMs. They're identical in that they run the same image, the same software. They have a built-in load balancer to manage requests inbound. They're great for workloads with varying demand. So maybe you have a web solution that normally works fine with 3 servers serving user requests, but maybe during peak demand, users would be served faster if you had 6 servers. Well, the purpose of a VM scale set is just that. It can scale automatically in some cases to 6 VMs when they're needed, and can even scale back when not needed to the 3 VMs that you normally have. When you set up a scale set, it doesn't cost any additional money to create the VM scale set resource. You're paying for all the VMs that are behind it that are running at any given moment. So it can be an effective way to get extra hardware when you need it, and then return the extra infrastructure hardware when you don't need it. There's an involved example, which we'll look at now, for how to create a scale set and then even set up the scaling. To create a VM scale set, let's go to the marketplace. Search for scale set, virtual machine scale set, and create. There are many tabs to configure here. Let's talk about the choices. On the basics, we'll do the general first choices. Choose a resource group, give a name to our resource, VMSS1. Choose a region with the availability zones, and then information about the image and size of each VM that will be in your scale set. I'll leave the defaults here. Like for any Linux VM, you can choose authentication type of password or SSH public key. Next, we'll go to disks. On the disks tab, choose the size of the OS disk for each VM in the scale set, and also OS disk type, SSD or HDD, and how it's going to be encrypted. I'll leave the defaults here. You can define additional data disks here if you like, if each VM needs one, or you don't have to. Next, we'll go to networking. On the networking tab, you configure the virtual network where the VMs will be running. Note it has to be in the same region as the VM scale set. Each VM will also have a network interface. Next, we'll define scaling parameters. As you can see here, initially, my scale set will have 2 instances. So 2 VMs will be deployed according to the parameters I specified earlier. A VM scale set will scale up to more than 2 VMs if needed, and you define the rules for that. You can define the default as a manual rule, which means you go to the portal and spin up a new VM, or you can define a custom rule. Custom rules allow you to specify a minimum and maximum number of VMs, and then what the conditions are under which Azure will add a new VM. In this case, CPU threshold gets greater than 75% for 10 minutes, add a VM. I recommend leaving this as manual during setup. This is easy to change in the portal after. Keep it simple during setup. You can also specify information about a scale-in policy. So just like Azure will automatically scale out a VM, it'll scale in a VM when certain rules are met. And so you can decide or indicate which algorithm Azure will use to delete unneeded VMs. Next, we'll go to management. First thing to specify here is an upgrade policy. So when you change the parameters of your scale set in Azure, then Azure needs to know how you want it to roll out those changes to all the VMs in your scale set. So the default choice is manual, but you could also choose automatic so that Azure will automatically start upgrading your VMs, or rolling upgrades. If you do rolling upgrades, then you define what percentage of the VMs should be rolled forward in batches, and what the pause can be, and so forth. Again, I would save this change until after the scale set is created. Boot diagnostics are turned on by default for the VM. Over provisioning allows Azure to sort of overshoot a scale out operation and then delete the extra VMs once things stabilize. This can be a nice way to help stabilize an environment where your scale set got a large demand load at once, and you're not billed for the extra VMs in over provisioning. So it might be a good thing to consider turning on. Automatic OS upgrades are turned off by default. You could explore turning that on if you like. And also, do you want to be notified as instances in your scale set are terminated? Next, we'll go to the Health tab. Here, monitor application health is turned off by default. If you want the scale set itself to sort of watch the application that you have deployed to it, you can enable this. And then let's say it was an HTTP application and you were listening on port 80, you could indicate a custom path in your application. Azure will automatically send probes to each VM at the destination you specify in the application, and then monitor the status. This can be helpful to know if a particular VM in the scale set is answering requests from users properly. And if you have that turned on and you want to do some automatic repairs, you can turn this on as well. And what this will help Azure do is if it notices that a particular VM is not healthy over a period of minutes, in this case 30 minutes, then it will just tear the VM down and perhaps build up another one if scaling indicates it's needed. So you can really let Azure help you manage the applications that are running on the VMs in your scale set. Next, let's go to advanced. Here you can see that scale sets are initially limited to 100 VMs per scale set. If you need that number to be larger, you can request it with a yes. And then the spreading algorithm just indicates how your VMs will be deployed in the Azure data centers. So a VM scale set has an availability set built into it. So by default, it spreads those VMs around on different fault domains in the data center. So they have different power supply and network interfaces. Extensions that you might push to each VM can be defined here, as well as some other custom data that also you might want to save and do after the scale set is set up. At this point, I can review and create. Azure will validate what I've entered. I'll download the key pair since I specified that for my Azure, my Linux VM. And we'll come back and look at the result of my scale set in a moment. Here's a VM scale set I have created called VMSS1. On the overview blade, you can see options to stop all instances in the scale set or restart, also to start if stopped. Under the instances blade, you can see that I currently have 2 VMs deployed in my scale set. Both are running. They're in an unhealthy state because I turned on an application health probe and I haven't deployed any code to the VMs yet. You can also see here that the latest model is set to yes. If I click on a given VM, I could connect to it. I could stop or restart the individual VM or upgrade. So if you change the model, if you change settings in the portal that affect all the VMs in the scale set, Azure will push those changes out to each VM. The default is manual, which means you would come here and do the upgrade yourself. Let's go back to the scale set. Under scaling, manual is my current setting. And so you can see I have 2 instances and I can change that number up to 100 if I like. I can also set up auto scale. This is one of the most powerful features of a scale set. So scale based on a metric, add a rule, and then you fill out this screen. So as you read this, when the average VM percentage CPU time, and this is just showing you what the average has been. So when that average is greater than 70, and you can fill in any value you like here, for more than 10 minutes, then increase my count by a certain number of VMs. Those other choices here, increase percent, increase count to. So this is what we would call a scale out rule. And it would indicate when Azure was going to add a new VM to my scale set. You typically also add a scale in rule as well. So a scale in rule, you fill this out maybe the same way. If it's less than 25 for a certain period of time, then decrease my count by 1. So the combination of these rules will mean that your scale set can add new VMs when demand requires it, and can then take VMs away when they're not needed. This just saves you money and also makes your scale set more responsive to customers' needs. So it doesn't cost any extra to do custom scaling. So I say turn it on and configure it the way you need to for your environment. Let's click Save. So now Azure will manage the scaling of the VMs in my scale set. Other choices here, here's information about the disks for each VM. There's the OS choice I made. Here's the VM size, which you can change if you like. One other thing you need to consider for VM behind a scale set is how you're going to get the application deployed. You don't want to think necessarily in terms of accessing each VM, because in a scaling situation, Azure's going to add VMs to your scale set. And so you need to have a way to automate the deployment of your application to that VM. One of the easiest ways to do that is continuous delivery. So you can use Azure DevOps or GitHub or other choices, and you can deploy source code for your application right into the VM as it's initially set up. So definitely best practice to configure some continuous delivery here for your applications that are deployed to scale sets. The other choices here are things similar to what we saw during the setup. And I was recommending you wait and make some of those choices later so you can explore these options here under configuration, upgrade policy, and also application health, and make changes as needed. So in the demonstration, you saw that if you turn on auto scale for a scale set, you get to set the min and max number of VMs that you want to scale to, and you can establish scale rules based on metrics, for example, CPU utilization, or based on a schedule. If you choose metrics, it's a good idea to have two rules, a scale out rule and a scale in rule. So that means you're going to get extra VMs when you need them, when the metric you're watching is being taxed and crosses the threshold, and it'll scale in, scale set will scale in when you don't need those extra VMs. So scale sets can be a very effective way to manage a workload, particularly ones with varying demands in Azure. To finish this topic, let's compare a VM scale set to just a regular set of VMs you might deploy in Azure. So the second column here, manual VMs. The third column, virtual machine scale set. What you notice is that the manual VMs that you create also have manual configuration for various scenarios. You have to create each of the VMs. If you want a load balancer in front of a set of VMs, then you have to create that. You have to create an availability set if you want some high availability, as discussed in another lesson. You have to scale the VMs yourself just by manually monitoring. So scale sets solve all those problems. Notice the word automatically and auto scale in all of the scenarios here. You pick a base setup, Azure will automatically create a new scale set, or no, a new VM to put in your scale set when needed. A VM scale set already has a load balancer built into it. You can choose which type. These are discussed in other lessons, the load balancer, application gateway are two of your choices. A VM scale set also has an availability set or availability zone built into it. So that's even set up for you. And then, as was discussed earlier, you can auto scale based on metrics or based on a schedule. So VM scale sets, in a way, are an easy choice if you're deploying to a VM and you do have varying load. They don't cost you any extra money. And it just means that Azure will help you with managing performance for customers or users who are using your solution.